We're going to talk about polar coordinates and what those graphs look like. So it's super important that you, on your calculator, that you change your mode to polar. So you need to change to polar. And when you change to polar, if you go to y equals, it's no longer going to say y equals, it's going to say r equals. And when you try to put in an x variable, it's no longer going to say x, but it's going to say theta. So you are changing to the polar coordinate system on your calculator. So to graph polar equations, you can make a table of values, which the same table on your calculator that you use for the rectangular coordinate system, you can have the same table. So r is dependent on theta. And we want to test values in intervals of pi over 6. So example 1, let's graph r equals theta. So in your calculator, if you go to y equals, it won't say y equals anymore, it'll say r equals. And then if you press the x button, what you used to press for x, it should now show up as a theta. So if you do that, and you can go to your table, if you hit second graph, and let's take a look at some of these values. So if you plug in 0, you get 0, pi over 4. So we plug in these values into our table and we get these answers. So now let's plot those points, right? We're going to plot those points. Or you hit the graph button, you should get something very pretty like this. Okay, so now r equals 5 cosine 3 theta. Again, go to your table to get these table values. And then once you have these table values, you can graph these points. Simply hit graph on your calculator, and you should get something really pretty like that. R equals 3 plus 2 sine theta. Plug that into your y equals, which is now r equals. Go to your table, find these values, those points, or simply hit graph so you can sketch it. And you should get something like this. Notice that this is not a circle. It's a little arched right here and almost kind of makes like a little heart right there. Okay, so let's look at r equals sine theta. We have these values, and I'm putting these values, at the same time I'm putting these values, I'm also plotting the points so you can see if you were to do this by hand, which you won't have to, you'll be able to use your calculator to sketch it. But this is where these points are coming from. It makes a nice little circle there. Okay, so let's try these bigger values. There you go. So now let's do r equals 3 minus 5 cosine theta. You plug in these values to get these points, and you get a spiral. Okay, so the bigger points will give you the other part of the spiral. Notice that this little piece, it's almost like a little loop right there in the middle. Okay, r equals 3 sine 2 theta. You plug in these values. Notice that we're in degrees now and not in radians anymore. That's okay. Just make sure that on your calculator, instead of being in radians, we're in degrees now. So these points give us this shape. And it's like little petals is what we're doing. So if you do the higher degrees, we'll get the petals on the other side. So when we're talking about equations that are in the form r equals k sine of n theta, or even r equals k cosine n theta, any equation in that form, the n value is going to determine the number of loops. So if n is odd, there are n number of loops. And if n is even, there are 2n loops. And these loops are called petals because the graphs are called roses. There are roses. Those are actually the technical name for those graphs. So, for example, if I have r equals sine 3 theta, that means that I have a graph with 3 petals. If I have r equals k sine 2 theta, that means I have a graph with 4 petals. So your turn, try 6.7, 2 through 6 evens. Remember, in your your graphing calculator, you need to change to the polar coordinate system. That's the first thing you need to do, is change to polar, and then make sure that you're in degrees or radians, depending on the question, and make sure that that's also correct. And 236 is due in class with your notes.